Anyway, nice to see you guys. Hope things have been going well. We were originally going to chat through some things. I was hoping to get some more people's opinions on some of the items here, at least. So I could just, we'll put out a notice for people to think about it. I'll just move on to some quick reports. I've been going through, Devin, I've been going through the doc strings and things, editing it. Basically, I've just been going through, putting in a bunch of edits and cleaning up some of the, like just the formatting a little bit, just making it thing. And as I've been going through, I've been trying to keep track of things. It's like, so we can have a document. Okay, this is the, like where it's where like the NumPy style guide leaves things ambiguous. Like we need to like, okay, well, let's just, choose a style and go that way. Like just, so it's at least codified somewhere. Things like, okay, well, when describing the shape of an input array, where do we put it? How do we define, how do we say it? Just simple thing, like so on and so forth. Just think, yeah. So I've been going through and editing it. I think I'm gonna push what I have as a PR onto that docstring branch, so you can see the type, like all the edits that I was making, and hopefully that should like key you in, like, okay, well, let's do it. Like I see what's going on. It's things like if you leave blank lines in the examples, it doesn't like it when it formats it in the output, because it does this weird thing where it's like you can now select those 3 arrows instead of before, like if you highlighted them all, like it just would ignore them. So like it's like one of the things, like I don't want to, like we shouldn't have just blank lines in those examples, like with like blank code lines, I guess.
Really, I guess if you have 3 arrows and then a space, though, it'll be a part of that script. And
Yeah.
I don't know. I guess the thought was like when you have no spaces in your code and everything's squished together, sometimes it's not the nicest to read. I mean, yeah.
I think what would happen, or what would be the best, is just to leave like an actual blank line and block it up. So like it looks like, so when it outputs, it looks kind of
like a cell demarcation or something.
yeah, like it'll look like a cell demarcation. Um, and the reason is that it's like most editors will kind of, or some editors will automatically remove trailing white spaces on lines that are pointless. So like that would be a trailing white space on that line that it's like, oh, I don't need it, never mind. Like it's, some of them tend to be a little bit more
Okay.
than you want them to be sometimes. But it's I think it looks a little bit cleaner in the output, at least just have the breaks like that.
Well, because right now when we generate the website, it's fine. Like, I mean, it looks like how I wanted to generate. So what kind of an editor or system are you saying it's going to be kind of buggered on?
I know, I'm just saying like some editors will like usually, so trailing white space in like Python lines can get removed by when we run black on code. So that's one of the things that it looks for when we've been saying we want to run black on all of discretize, or if we want to run black on all of SimPEG, it'll remove trailing white space on lines.
So just replace all of those with like hashtag %% or something?
Even, I would just say, just make a blank, like a fully blank line in the doc string there. Just so
yeah,
like a cell breakup at that point.
Okay. Yeah, and then we'd have, okay, yeah, we'd have those guys, and then, okay.
Yeah. Yeah, just because of like so like I said, like the trailing white space just gets deleted by black.
I don't know. It seems like it might look a bit uglier on the website because it's gonna have it would have separate code blocks, and you'd wonder why it's separated when there's no kind of text in between telling you about that. I mean, if you're saying this is a major issue we're for sure going to encounter, and you're also saying we want to run it through black to ensure formatting, then like it has to get fixed.
Yeah, like yeah, like we have to run it through black. Like I'd like to run it through black to make sure it's all consistently formatted every time, like we've been doing, like we're doing with SimPEG.
Yeah.
So just like simple things like that though. And then another thing, when we have like continued lines,
Continued lines.
it's like a continued line, like it's an expression that's continued onto multiple lines. It's like you use dot 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 instead of the arrows. Like the point is, it's supposed to look like a terminal. That's why like it's formatted like that. It's supposed to look like terminal input and output. Like if you open up the Python terminal.
Yeah.
So just I was doing things like that, and then kind of just keeping it, like removing like extra spaces when there's like, oh, we've got like two lines here that are kind of like, only one line would be sufficient. You should, it'll just be a bunch of stuff like that. I've gone through most of them, but hopefully you just go through and apply the same formatting to the things like the utils and the rest of the classes.
Yeah, the biggest, I think maybe the biggest thing that I have right now for the pull request is sort of like global failures of the doc testing. And it's always been something where it's been kind of hard to get, like pinpoint the line where things might be breaking. And yeah, maybe I'm missing a place where I can kind of find printouts of stuff like that, but I can run the tests locally and everything would be fine, but then you're testing it for different operating systems and I'm not able to go and find, oh, okay, like this link broke, or, you know, it took me forever to there was like a piece of code that was dependent on the operating system for like connecting file paths and it didn't work on one operating. So I don't know if there's a way we can kind of get more comprehensive write-outs of that stuff, but that seems to be, I'd like to be able to have the pull request be passing at this point, and it's not for all operating systems.
I can look into that a little bit more. It is kind of hard to parse the output of the documentation build script, because so much stuff, like it just puts out so much information.
Oh, for sure. But I guess most other stuff, it'll give you a line where it failed.
Yeah.
And with the docstring tests, it can't give you a line where it failed.
Yeah, it'll just.
Although, I guess also, I mean, so it's obviously it's going to pass on Windows because I'm using a Windows operating system. But one thing that I guess would be really helpful is if somebody using one of the operating systems where it's failing is going to build that locally, and then they would be able to kind of figure out what line. That might be one way of figuring it out.
Yeah, I was also able to. Yeah, let me show you one quick thing about how it looks right now. And you can see what it looks like with like the broken up without any text in between. So I was going through here, just kind of editing some of this to make it a little bit cleaner. So like here, okay, you talk about what you do. Like it's, to me, it's really clear. Like, okay, well, this is, you know, constructing a mesh, and then I'm just plotting it here. Maybe we could separate this out up here into this one.
Yeah.
And then it's like, okay, well, this block literally is just plotting it. So it's not, it doesn't look awful.
Yeah, that's fine.
Whereas here, like, see what I mean? Like if you're doing here.
Ooh, there's a little typo under no space, but yeah.
Yeah. So like my point is that's what happens. That's really awkward. And then I was able to get these to show up in line. I think you were using Fig here, and it should just be plot.show.
Oh, I see. So when you ran it through black first, and it got rid of the space that I had after the 3 arrows, which made it actually formatted nicely.
Yeah.
And then now it's basically like I only typed 3 arrows instead of 3 arrows in a space.
Right.
Yeah, I see. I mean, you can also just put like a comment line if you're really. It's fine though. No, yeah, no blank coding lines. Something has to be there. That's fine. And then we can just separate it. Yeah.
Yeah.
Can you go up a little bit? And then up a little bit more. Up a little bit more. Just like to the theory section. And then I guess a little bit more. Yeah, sorry, with the inputs. So I think you changed, I don't know if you did, but you changed the columns are ordered, and then you basically provided a definition that's sigma XX, sigma YY, sigma ZZ. But then scroll down to the mathematical definition. So it's now inconsistent with that. So we need to
decide. Yeah, which way is more clear to me? I don't know. It's hard for me to remember, like, okay, which one was sigma 4, which one was sigma 5. Right, when it would be 2D, it'd be like sigma 1, sigma 2, sigma 3, right?
Yeah.
I
mean, it should be fine. Like we can always we can have sigma xy and then sigma xy, and basically you'd recognize that it's symmetric matrix.
Yeah.
I guess I'm saying be a little bit careful when you think about formatting, because there is math and the things need to be consistent.
Yep. I was literally just working on this one, like just before, and I hadn't gotten that far yet. But
okay.
That's why my thought was like, okay, well, when it's at least this is like, these are the diagonal elements, and these are the diagonal and then the off diagonal in that order.
Yeah. Yeah, that looks really good though.
And
cool.
then
I mean, let me know when you're finished.
yeah.
And I don't mind if you just bring it in, and I'll see what you did and go through it.
I was able to get things look nice. It's all format nice. Just kind of going through stuff, but
yeah, it's looking slick.
It's nice that it's able to automatically link through all of these things. Like, oh,
yeah,
what is this? It's like it's actually links to tensor mesh dimension. Like it's very consistent. Like it actually is that thing.
Mm-hmm.
Yeah. Which is one of the things I'm doing. Just kind of giving a tour of what it's going to look like. What me and Devin have been working on.
And you seem like you're pretty happy with the length of things, having the images, things are in the right place. Like globally, you seem like you're pretty happy with how this information is organized.
Yeah, yeah. Like I haven't been doing too much. I've been going through and editing some stuff. I'm like, okay, well, yeah, it makes sense. Just, small edits here and there.
Mm-hmm. Okay.
I do want to get some people's opinions on, like, besides just mine, on what you feel is necessary for some of the, like, let's take a look at the cell gradient operator. As far as the examples. So this is the first example, right? Just taking a simple gradient of a scalar property and plotting it. And then there's another example where about the mapping here. my only hesitation about the mapping thing is it's nice to have them and see them. It's just a lot of plotting code.
Yeah.
You know what I mean? Like it's unfortunate. It's like, yeah, it's just a lot of plotting code is my only hesitation with them.
I thought, I mean, well, we want to see how things are generated. One thing I thought about this, because I was reusing things, was like putting in kind of a hidden utility or some hidden functions that no one would ever use that would shorten it. But
Yeah. So like for example, like it looks kind of weird, especially on this like edge inner product here, or the edge curl matrix. Like there's a lot of plotting just to do a 3D plot, right? And then
yeah, I was kind of hoping that there would be a way to kind of put them in a reverse order. I know that's, I mean, it has to run the code and then generate it, but it would have been kind of nice if there was a way to put the images up front and then say, do you want to see how this was done? And then you would see the code.
There's little things we can do to actually collapse the code and have that be possible later. My instinct is I think these are worth keeping. And you know, if later on, if we want to parse them into little utility functions or like a little, you know, almost like a little teaching module for Discretize of here's some useful plots for understanding what's going on. But just being able to see that, I think, is really valuable, even if the code is a bit clunky right now.
Yeah. Like I said, like it's definitely useful to see that, and it's very helpful to visualize what it's doing. My only hesitation is that it's a lot of plotting code. Like
That's true. But if you, I mean, if you're going to look through and you'll see the meat of it, and then you'll see, oh, it's a bunch of plotting, and then you'll scroll down and see what the plots are. I think we touched on this maybe sometime in the last couple of months, and the consensus at that time was, oh, not to worry about it too much. Like they can scroll down and get more information if they want, but the important thing is it's there.
Yeah, like I like it there. So
you guys spent a lot of time on those plots.
Yeah, I know. Like maybe something in the future we could look at too is just like having them statically generated and then included.
Like basically building them somewhere else and then just
including them there, yeah.
Including the photo, yeah. Yeah, I thought about that as well.
So. Okay. It's about all I had for quick updates. I'll give it, I can also try to show you guys a quick stopping, like the stopping criterion thing that I was working through. I was showing Lindsay, T-Bill, and Doug the other day, but I can show you guys really quickly here too. Get to it. You can move on while I'm finding it. Devin, go ahead.
Yeah, well, I think we basically covered all the docstring related stuff. I've already gotten started on the SimPEG docutils. And then a second thing I've kind of been working on has to do with 3D time domain EM code. So I've been doing some validations between analytic solutions, SimPEG, and the UBC GIF codes. And overall, that's going quite well. And now I'm at time domain EM, and we saw that I think there was an issue with the UBC GIF because of solving like a magnetostatic problem at the first time channel when you have susceptibility. So that kind of led to some code development in UBC GIF, and we've kind of cleaned up a lot of that, but then validating it against what SimPEG has. And when you have a purely conductive model, there's great agreement across all of the codes. But when you add susceptibility, the SimPEG code seems to be pretty problematic. And I don't know if it's, I'm sure we've worked on this with several projects, but it really depends. What are you measuring? Are you measuring E or H? What is your source? Is it galvanic? Is it inductive? And I'm sure that when it was developed, there was some testing to make sure that it was accurate for the situation we needed it at the time. But yeah, I've noticed that for just having this inductive source, like a loop sensor in the middle, for a layered earth and for basically a sphere in a vacuum, it's not particularly accurate, and it's not very stable for later time channels. So yeah, I'm just kind of looking through and trying to understand ways that we can improve it. The TD Octree codes, the version 2 code seems to be really good. It solves for the electric field, and it integrates over the receiver loop to give you dB/dt. And there was also some consideration in the stability due to hanging nodes. So I think that code might be a little bit more developed than what we have in SimPEG, but yeah, I think there's some work to be done to if we have susceptibility.
Deb, that's something I'd be very happy to do a bit of a deep dive with you, or sort of walk through what you've done so far. I've done a lot on the cylindrical meshes with susceptible targets. Most of that should hold for the Octree meshes, but the testing, you're right, is probably not as extensive. So I'd be very happy to work through that with you and kind of see if we can make some headway there.
Yeah, that sounds great. Yeah, I think there's just some improvements we could make, maybe in the formulations, but then also for how we're defining sources, and then how we're going from the solution of the fields to the receivers. Like we've kind of got that first level of implementation of the finite volume method for all the ways that we could do it. But then I think there's a level of improvement that could happen when we really get into it. So yeah, that'd be sweet.
But you did do a comparison with the SIL code and the UBC codes for the sphere in a layered space, did you not?
No, I didn't do a sphere in a layered earth. I did a layered earth separately, and I did a sphere in a background separately. Or sphere in a vacuum, sorry.
Okay.
Because that's the weight and spies, or weight and spies analytic solution.
Okay, well, again, as Denny just said, this is really timely to, get to the bottom of this, and yeah, for a whole bunch of reasons. So we can continue discussion after.
Yep.
Okay. See, John?
Short update here, I guess. All the tests are passing finally for simulation MT PR. Thanks, Joe, for taking a look at that. I didn't even think to look at I was passing on my computer, but yeah, I wasn't passing, but I had the old version of, I guess, HDF5, the new module download. Yeah, should have thought to look at the update.
No, I only caught it because I saw there's like, why is this? I knew it wasn't failing on my computer either, but it was on there. Like I can see where the line it's failing, and I was like, oh, it's an HDF5 document. I wonder if they switched something. Then I went up and like started playing with it on my computer, and I got like a deprecation notice that's like, oh, this way of accessing it is deprecated.
There it is.
Oh, okay.
Nice. Yeah. Yeah. Thanks a lot for that, Joe. Yeah, that's all passing. So now it's just the code cov stuff. Yeah, I don't know what we want to make that all passing too, make everything good.
I would hope, yeah, go ahead. We'll probably write some more tests, write some more tests to hit those lines or hit, big chunks of lines that are missing.
Okay. Yeah, I was first kind of pass at CodeCov. I haven't been involved with it before, so I was just taking a look, and yeah, I can make sure I can start tackling that.
It's pretty. If you go to the GitHub, so I'm not sure how you were doing it.
Yeah, it was through GitHub.
For everyone else, if they're looking. Yeah, I'm just gonna do it really quick so we can see, we can get on the same page.
Cool.
So we were talking about the MT simulation, right?
Yeah, the part one.
So if you're going to file, like the changed files, you can go through here and see very quickly like what lines are not covered.
Okay.
Right? Like, oh, this line's not covered. Like this, none of the tests did that.
Oh, so you need okay, you got to write the test. You got to make the test so that it hits those ones. So there could be if statements or something that it never ever hits on the test.
Exactly.
Aha, get you.
Like this is a way you guys can go through and see like what lines are actually not getting tested very quickly when you're doing that, when you're doing these.
Okay.
It's like, oh yeah. Like why is this? Like hopefully we'll be able to get this thing connected somehow. It's mostly just, you can see here. Just search through the files changed and it's pretty obvious which ones are missed and you can write some tests to hit them.
Oh, okay, cool. Yeah, no, I can tackle that next for sure.
Thank you.
Other than that, still waiting on getting access to my cluster. So no fun stuff yet.
I see TiVo on there next. Yeah.
Yeah, I mean, we talked about it yesterday, but just it's an ongoing PR, like it's still a draft, but putting together like a PR, bringing several improvements to the current PGI, like better default, so for user and quality of light improvement, couple of typos, like small bugs that happen in a very, very specific case. But most importantly also is that finalizing the implementation of the gradient and Hessian for arbitrary physical property distribution. Like no longer, like the current code was mostly focused on when you had like distinct clusters, so like distinct units that were not overlapping, but now with the PR, like SimPEG will be able to handle any physical property distribution represented as a GMM, and that even if they are overlapping. And that's a nice thing because like GMM can approximate any continuous distribution. So that brings us so that brings that a lot more flexibility to the code. After that, I haven't had a case yet where like it's really like a key features, because we were often looking at we were always often looking at like in like with TKC or others, like at more like things like a distinct anomalies in the gravity and magnetic. But I think that will be a nice addition for other application. We'll see. I see Sogi being very thoughtful.
I was just thinking, like, what does that? Because there's no meaning in space, I guess, like, because you're actually thinking about actual distribution of physical properties, like overlapping, in just like a value-wise space, I guess. So. That is a reality, I think. Values are overlapping. Not very distinct cluster in general.
Yeah, after that also, it's also how you can see it with geophysics. Like even though like they might be overlapping, because the means and are rather different, that you can still picture it as something that distinct from the geophysics. But yeah, it's
if you make it like so you're getting a large variance now, then would it make the spatial distribution smooth still, or it may actually not the case? It's still your spatial distribution could. My guess, I think it may impact your spatial distribution if you're getting a large variance. I think it's probably smoothed out, or like some random.
Exactly. Like if you have large variance, yeah, you have something that's smoother, and that's kind of what I was presenting, that empty 1D like synthetic example, just to show that like you have like one unit that was like very sharp, and we could get like a very blocky, like a block, while the other one was very smooth with large variance, and we were also able to have that smooth feature. So like we were able in the same inversion to get blocky and smooth features. So that's kind of, but they were still distinct, like when you were looking at the probability distribution. But now we're like looking at more like, yeah, as we say, like overlapping clusters, or if we want to fit a specific distribution of physical properties. But yeah, with that, I think that one thing we need to change thinking about that is that now, like when you do that, is that reproducing the physical property distribution is more important than categorizing. Because that's the thing, with when you had like distinct clusters, you can with strong confidence say, okay, that from my inversion, from the result, this cell is going to be categorized as belonging to these clusters, and this cell belonging to that cluster, and come up with the quasi-geology unit. While in that one, like that categories is not as sure, or like it might not even matter. It's just like you want a specific distribution of physical properties to be recovered. And then later on, you like, I think like with Jaja, with Fuzzy was doing something like they was calling like defuzzification, like they were trying to pull either like the most important one, the most likely one, but yeah, it's just it might be like for different goals.
Right, I see. So you're actually interested in, let's say, quantifying a bit of uncertainty in like a let's say your geologic unit versus let's say resistivity or whatever physical property that you work with. Is that kind of what you want to aim for by doing so?
No, not really. Like because for uncertainty, for me, the only way to do that is you have several models, you have several outcomes. Like if you have, I don't be like, if you have a single outcome, even though you have a cell that's like, oh, like depending of my physical properties, it's like you can get different its probability to belonging to each clusters. That's still one outcome, and it's gonna. I don't think it's like gonna be a proper way of addressing uncertainties. Like, yeah, like you need several outcomes for that. But it's more like if things are like not Gaussians, or if you're interested in something like I'm thinking about also like a Randi's distribution that's like very complicated, like when you look at the plot of density versus susceptibility.
I see. Got it.
Okay. Well, I've got my quick sketch of the stopping criterion class pulled in there. Thanks for putting that link in there, Lindsay. I'm just going to share the screen really quick so you guys can see who haven't seen it yet. It's basically a very, very bare bones implementation. It's kind of just like a sketch of what I was thinking through it. It's very simple. The base class just defines how we combine them. and it uses binary operators. So it'll use like the AND operator, the OR operator, exclusive OR, and then not. I've just defined those, and then how to combine them. So the idea is we would extend a user or someone would extend to this class and define their own custom call. So for like an iteration stopper, we would initialize it with some maximum iteration, and then it just compares it to, it returns the Boolean whether or not it does that. Similar for like a target, for example, like a target misfit stop, or if somebody would, let's say TiVo wanted to do a PGI condition thing where it was, had a picture target and it was comparing it to some value. It is that we can define all of these individually and then arbitrarily combine them afterwards. So let's say I have something that looks like this. We have an iteration. I want the iteration to stop at 10. This target misfit, once the first data misfit hits 60, that one's satisfied. Once the second one hits 240, that one's satisfied, and so on. And then I combine them. So this would provide a simple stop condition, or this would be from like a more extensible stopping condition instead of having to define a new like inversion directive every time we have to implement another stopping condition. It's just another, it's just like another, oh, I'm just going to grab these stopping conditions and use them. It's a little bit, and I think it's a little bit, right now, the way we kind of have stopping conditions, it's very unclear where they're at and where you define them. Sometimes they're directives, sometimes they're passed to the optimization, sometimes they're passed, I don't know. Sometimes there's a lot of defaults that we can't see. But this is just kind of like a very, like I said, a very bare bones implementation of what I'm thinking. I like being able to define it like this. To me, it looks logical, like exactly what's going to cause it to stop. It's whether, and like all of these or this, right? And yeah, the only thing is like, there's not any sort of printing associated with this right now. There's not any sort of, we need to define like what object we pass to, we have to decide what object we will end up passing to the call to evaluate the stopping condition. My first guess is it'll be the inverse, like the inversion object that has like the stored information on there. Like that'll be the thing that's storing like the most recent picture or the most recent data misfit. That would be my guess. But just very bare bones. You guys have any thoughts?
So Joe, are you thinking basically like a directive, or is this, do you envision this as something that's distinct from that?
I think I'm envisioning as something that's slightly more distinct. I mean, it could just specifically be a stopping directive.
Because the spirit of directives is basically, things that orchestrate the inversion. And so it, like in that kind of broad definition, to me, it kind of seems like it's a natural fit, and maybe it's its own kind of specific style of directive, but passing it in as a directive, at least to me, sort of seems consistent with kind of what we're doing with the target misfit. It's not the same, like it's true, there's stopping criteria in the objective function as well, which there probably still should continue to be. But I think what I would envision as like a first pass, and be very curious to hear others' thoughts, is that the optimization might have its own stopping criteria, and the user might also define some stopping criteria, like what Joe's got an example of here, the PGI condition. So the user defined ones would go in as directives, And then the inversion, it has access to the optimization. So it would then just combine these two to like give us all of the possible stopping criteria. Would be just first pass thoughts, but I don't know if that seems like it jives or not with you or others, Joe.
I mean, I kind of envision it being a little bit more distinct in that the inversion could have its own default stopping conditions, stopping criteria, right? Like, okay, these are the defaults. And then you could always overwrite it or extend it in the same manner, right? You could just, okay, optimization.stop like is equal to whatever, like times equal.
Yeah, you could always get things
like
from
just reset it or add. Yeah.
Yeah, I really, yeah, I like this. One thing that I found with directives is that it's not kind of the most robust, and like ordering matters. And if you don't have a strong understanding of what's being done and the ordering that needs to happen, you can be running inversions and then wonder why it's not working. So, and also it doesn't sound like we have that many options for the starting trade-off parameter, do we? It's pretty common that we'll pick that starting beta based on like a eigenvalue estimate. And I wasn't really able to find something that just says, start with this trade-off parameter and go. I'm sure we have it, but I wasn't able to really find it.
My guess is that you would probably just not use that and then literally just assign it to the regularization, like just have it as
to the improv, like to the in problem. You can just set the improv dot beta is equal to 100,000.
Yeah, but that's like kind of getting into the code and then setting it as opposed to a directive that says start at this beta, right? Like when you think of how people are interacting with the code, we're trying to say, oh, okay, the directives are used to go and define the cooling schedule or the trade-off parameter. And now you're saying, oh, wait, we can do it, but you have to go in and then like set it, through the the instance of inv class instead of setting it as a directive. Like that's just not how we want people to interact with the code.
Yep.
I think this leads into a bigger conversation that we might want to table at this point, because I think this leads into basically, do we still want to have the inv-prob joint inversions? Do we like get rid of the inv-prob and just pass an objective function? So I think it's like totally a valid, completely a valid point that this is something we should address. But just want to make sure we don't sort of detract too much from sort of Joe's suggestions here of focusing in on a stopping criteria.
At least that's definitely valid. At least my thoughts on the stopping criterion is that it's just, I want something that's a little bit more transparent in what it's doing and how someone would extend it.
If that's the goal, Joe, wouldn't it like the first place is at least like making clear in the optimization class, like because it's sort of quite hidden. Like probably actually there are many people actually don't understand what those like kind of written parameters and tolerance and all of those things actually even mean, I guess. So maybe actually that's probably a starting point, kind of just making it clear what are the stepping criteria we have and how you actually set the variables there. And like what you're doing, it seems like a next level. Like, okay, now how are we going to structure like a class that can be used as a stopping criteria? Where I am also not sure which one is the best. It's somewhat fine line because if you think about the real, like what's used in the optimization, it's like they compare the relative gradient, how much increase you made in or decrease made in objective function. There are quite a few other criteria. I'm not sure necessarily that's kind of useful to expose to the user because it's somewhat advanced and yeah, and like if usually what I use is just a target misfit. Like, okay, I just want to hit the target misfit and stop. So there seems like a two levels, and which one do we want to expose to the user? That seems a question which I don't know. What's the good solution?
If I understand some of the stuff of what you're saying, are you saying that you globally want to stop the inversion if you're solving for your step direction and you look and you see that it's not accurate enough? Or because like there's a different, you guys are talking about two different kinds of stopping criteria. One of them is like stopping the conjugate gradient solver, and you set that in the optimization. And then you're talking about, and I think Joe is talking about global stopping criteria that says terminate the inversion if any of these conditions are met. Or
I think we're talking about the latter, Def.
Yeah, that's what I thought.
Because like if you look at the printing of that inversion in SimPEG, there's toll F, toll G, and a whole bunch of like variables that says, oh, we stopped because of that. But I think it's probably not clear for a lot of users, like, oh, what's that even actually mean? So I think that's what I meant. That's something under the hood in the optimization class used as a global stopping criteria.
Yeah. So we just need to document that. I mean, those are just settings for the accuracy of solving that, as opposed to a stopping criteria for the inversion, which is being set in directives.
Right. But the actual inversion was stopped because of that, which is kind of fine line. Yeah, I don't know. I'm not sure what's the best way to go. But Dev, you're right. Like we just need to archive it as a first shot and just explain what that means first. And once we got that, I think we can think of like whether we need to have more separate like stopping class or not.
The only reason I think it comes up is because it's like when you look at how like the sparse norms get applied, you have to like you might have to adjust like the default stopping criterion for like the relative update for a model maybe, because that's one of the things you're trying to do. You're trying to get to a certain point and then start applying sparsity to it. Like once the model is converged, you then start applying sparsity to it, and then you do that again, keep going. So it can be kind of odd to increase or okay, I need to set in order to turn off the relative update stopping criterion, because I definitely don't want it to stop like that. You're like, okay, I have to set that to, I would have to turn that to 0 or some very arbitrarily small number that it's never going to hit. Instead of just not using it.
Yeah.
Well, and then with the iteratively reweightedly squares, you bugger the thing if you use the target misfit directive. You have to set a target for the L2 and then a final target misfit, but in iteratively reweightedly squares specifically. But yeah, that's sort of getting to another.
I'm thinking more towards creating the extensible class to be able to better handle those kind of flexibilities.
Yeah, I mean, I like it, and there's nothing stopping it from looking at any piece and making an assessment and seeing if it meets whatever conditions. It's great that it would just all be in one place, and there would be defaults, or you could choose to add a specific condition. Like, I think it's a great idea.
Yeah, just for the simple ones, like I don't think it needs, like we don't, yeah, they're just some defaults, and that now the defaults are defined with these things instead of how they were before. But yeah, I'm mostly thinking about trying to make something that's more extendable than the way it is right now. I know it's something simple, just try to think a little bit about it.
One of the ones that would be really great too is like, you have a global estimate of your uncertainties, and then you're not really sure if you're over or underestimating. Then your stopping criteria could be based on whether or not you're starting to flatten out. You could kind of set some conditions that are more based on the shape of the convergence curve, as opposed to just saying the target.
Yeah.
You might have
I think it's kind of, it's clear to, I think, looking for it, it seems like they should live as like a special directive, like it's a stopping directive. Just in general, it's like kind of how I'm seeing it right now. It's like they're just generally a stopping directive. And yeah.
So what do you think, Joe, are sort of next steps for this conversation?
I maybe just keep thinking about it, keep it on your mind, keep thinking like, how would I be able to use this to define a, like a more like a complex inversion stopping criterion? Like, okay, if I was going to do a joint inversion, would this make it easier? Would this make it harder to define a stopping criterion? Just kind of think abstractly about it, and how you would think about how you would go about implementing it in SimPEG now, right? And think about, okay, well, is this going to be easier, clearer?
And where do you want us to put thoughts or suggestions? Is there an issue, or do you want to continue it in Slack? What do you think would be?
I mean, we can keep doing it, and we can do it on the curve note document.
Sure.
Thoughts on there, you can add to it, have some comments and discussion on there, right?
Is it on yours, or is it in the SimPEG?
It's on mine right now.
Okay.
But I put it in somewhere where people should be able to just comment on it.
Sure.
Yeah, we can start it there for now, and then we'll move it onto GitHub in a little while. Okay. Other than that, we were planning on doing like a PR thing, or we'd go through the PR, but I think I'm going to wait until there's more people here so we can have a larger discussion on that.
Do you want to give folks just a quick primer of the motivation?
The idea is like we're going to try to come up with a more sustainable structure of doing reviews, just so it doesn't end up falling all on one person to review, especially like the very big pull requests. So start thinking about ways like what you'd be willing to do, and like it might end up being treated a little bit more like an editorial process for a journal. I'm imagining like, okay, just kind of poking yourselves every once in a while. We might have automated things to poke people who have been assigned reviews. And then a while ago in the governance structure, and we were chatting about, talking about having like, I guess associate editors type of thing who would be more specialized and responsible for certain areas of it. So
yeah, that makes sense. For sure.
Definitely get back into that kind of conversation and start filling positions. If people are game to do that, I would certainly appreciate it.
That sounds great. so somebody like an editor, I'm not sure who it is, but the editor will assign those kind of jobs to an associate editor, and then will those are the sort of system that we're thinking.
We haven't fleshed it out. We're just trying to come up with something that's a little bit more, we can keep ourselves more accountable to doing PRs and like actually doing in-depth reviews of them. So if that is a structure that works, we can go that way. If it doesn't work, we can go a different way. Just kind of start priming people to start thinking about it. We'll have a little bit more discussion next week. My plan is to have a start of just kind of a status of all the current PRs on SimPEG, where we can go through and look at them and maybe, at least for now, have people like, okay, I'll do an in-depth review of that one. I'll do an in-depth review of that one. Type of thing. But so moving forward, I think it'll be more sustainable if we kind of move into that sort of delegation of tasks process. Anyway, anything else, everyone? Anything else anyone like to talk about?
Just briefly, I was like, now I'm getting into a little bit different types of, well, like more like a joint types of inverse problem. And I was wondering, like, you guys were thinking about doing how to implement like a cooperative types of inversion in SimPEG. So what I'm hoping to do in one step, I just want to invert, like update a part of my model. And still it's iteration 1, but I kind of want to switch on and off like certain things. And the current structure is not very natural to do that. So yeah, like I can make a very crappy inversion code to do that. But I was kind of thinking probably worthwhile to think about kind of expanding the existing structure such that it can handle that kind of problem. Because what's actually required is we need to actually change the mapping that we pass to the simulation, because currently it just assumes a full model. Like we need to pass every information, but we need some sort of ability to swap out, okay, like sometimes switch off certain mapping. Let's say if you're inverting for sigma and mu, and for one iteration, you need to on sigma but off mu, but the other iteration, you need to on mu and then off sigma. So it's a, I'm just thinking, but yeah, if like anybody interested in, hope you can think about it at some point, if we can chat at some point would be nice.
So I think one way to do it, the way I would suggest at this point is to do, it's a directive on the multipliers. And so if you change basically the beta value, well, not the beta, but whatever you're going to call your multiplier between your two objective functions, if you change it between 0 and like the 0 object in SimPEG and whatever value you want it to be, that will short circuit and not evaluate it. So if you do 0 times whatever, then like you don't have to change your mappings or anything, because you're just going to be adding, like you won't make updates to those model parameters.
I see.
So you just need a directive that basically like is a little ticker. It's like, is the multiplier of this value or is it 0? And then it should just track back and forth.
I think, and that, to get it to be most efficient there, I think you'd actually have to have 2 separate simulations though. Like you couldn't, I don't think it would be, I don't know how it would reuse like the same simulation every time. I don't know.
Well, because each data misfit takes a simulation. So if you're working with 2 distinct physics, those simulations, there's no overlap between them, other than they might take like similar meshes. But right. Those 2 data misfits don't talk to each other than in the addition. But basically what you can do is you can short circuit, like turn this data misfit off by changing the multiplier to the 0 object. And that always just returns, it'll give you back a 0 and it won't evaluate that objective function. So you're not losing anything in efficiency. Like it's not going to compute the data misfit or the derivatives for the one that you don't care about in that iteration.
Right. So let's say like you had the same simulation and you wanted to, like a electromagnetic simulation, let's say, right? And you're using it to do both, you know, the derivative with respect to sigma and with respect to susceptibility.
Oh, I see.
Yeah, that's probably more closer to what I was kind of thinking. You got a complicated physics, you got very like a multiple properties, then like and then such certain property, like the scale is so different. So even if you do a good job on scaling, it's just like it's not going to update certain things. So you want to like set certain things going to update and this like a first, and then move on to the other. So it's more like a what like a not sure what's called, but so Joe's comment was, I guess, like you may generate two different simulations and just iterate, alternate, I guess. Yeah. That's a potential, yeah.
That's fair. Okay, I see that.
But yeah, if there was a separate physics, then yeah, I think what you have suggested is, I think that's the way to go. I think. Okay.
That's a cool question.
Yeah.
Anyway, yeah. I'll probably do something.
Maybe do something to just make sure it's like, okay, if it is. We need to like something like the equivalent of like a block 0. It's like 0 blocks or something. I don't know. Just trying to think about how to like make sure it doesn't evaluate, like if you have a bunch of zeros, it doesn't evaluate part of the model. Like let's say like you're right, that whole U vector is zeros for all of the sigmas, like the corresponding sigmas, right? Like it wouldn't, like it would just not do those sigma derivatives.
One thing I think that we could do that wouldn't be too messy is actually in that invertible property like base class. So within SimPEG, there's the invertible prop or whatever we call it. And it has different attributes. We could just add an active attribute that's either true or false. And then that could be the thing that you switch on and off. And the logic then throughout the code, I don't think would get too messy. It would just be, if this thing is active, then go ahead and compute the derivatives, and if not, then don't. And then in that case, the switch, like you would only have to touch one thing rather than messing with all of the mappings and stuff like that.
Interesting. Usually the way that we've checked if they're active right now is if it has a mu, like a mu map or something, right? I think that's generally how it's checked if it's active now. So it could switch around to be doing something like that.
Yeah, actually, I like that, passing that flag. Okay.
Okay, interesting.
Because what's then kind of nice about that too is actually if you wanted to basically set up the same simulation and you want to provide a model, but now it's for a fixed mu and you just don't want to invert for mu, then you don't have to redefine all your mappings and stuff like that. You just say, oh, I have a mu mapping, but just don't invert for it.
Yeah. Then what's your model like? Because your model, because that mapping defines your model, I guess. So,
well, the mapping defines how you get like mu from your model, right?
That's true.
So the model is the same thing. You're just not using part of the model vector, essentially.
Well, you're not computing derivatives for part of the model vector. You'd still use the whole thing. You would just never touch. You would never make updates to one chunk.
Any like derivative of this, like that step direction would be 0 for all of those parameters. Like.
Okay. fair enough. I actually, yeah, that sounds actually not too hard to expand the current code by doing so, I guess.
Okay. Well, have fun with that, Soggy.
For me, nothing particular. I think that was, I don't have any update. It's just bringing in more questions. Not very productive, I guess.
Well, then, I'll see you guys all next week if there's nothing else.
See you.
Take care.